Gentlemen, welcome back to the shop. We've cleaned off the healing bench here in order to autopsy another unwilling victim. This one, something special. These are crawl sensors, hydraulic industrial automation, big ticket items made in Österreich, land of the dirtle, drindle, anyway, those things. Yeah. So we're gonna poke, prod, and massage these things till they release the shmoo. And what these things are hydraulic flow meters that are extremely low slip. 0.1% accurate these things are. What I'm using them for is for the hydraulic bartending robot. Because we need, for any kind of robot, for proper positioning, we need feedback to know exactly where the effectors are. There's where these come in. Now, I gotta thank the patrons. There's 3,500 guys that come into the shop, share a laugh, put in a couple bucks into the pot. Thank you. I wouldn't be able to do this without you. I mean, I'm just a dude in the shop, and these things are 10 grand a piece from an OEM. I didn't pay that, mind you. I paid quite a bit less than that, but I've been keeping the money budgeted aside for exactly when something like this comes up, I can jump on it at auction and pick it up. These things are skookum as frig. I'm gonna take this one apart and show you how it works. It's fucking amazing. Now we're gonna pop the top off here. Now, of course, potluck. I don't know if these are actually working or not, so we'll take it apart and clean it up and see if it's not working. We'll get it to work. Need the grinder marteau. The thumb detecting nut fucker didn't do her, so the proper thumb detector should. 32 ounce. There we go. Before the days of being PC, because I'm very PC, we would have called that an old Indian trick. Son of a diddly. Those Austrians know how to torque a fastener. So while I'm at it, I'm just going to tighten these, or snug these back up, and then I'll loosen the opposite side. Same thing on both sides. Well, same bolt pattern. A little bit different though. You can see there's some additional fuckery going on here. We'll get to that momentarily. And not to worry, chillins. For all you guys in shop 10 grade class, I got my safety squints on, and this is S2 tool steel. If you look it up, S2, impact resistant. Whew. Somebody from Texas tightened that. Nothing tighter than stripped, am I right? Speaking of Texas, they also use these not only in hydraulics, they use these in the petrochemical and probably anything where they need to meter something. For instance, mining. Not just in hydraulics, but also in the mineral processing side. They are very specialized and, as I said, high-end. I mean, it's from Austria. What gets made in Austria nowadays? Music boxes, dirndls, and these things. Okay, here comes the shmoo. Oh man, lots of shmoo. Shit. That happens sometimes. Expecting just a little squirt and you get the whole bachelor party's worth. This should be a clue to you what's going on here. It's almost like it's threaded. Okay, but anyway, this is a chopper shaft on this side, and these are PNP proximity switches. And what happens is there's two, and as you'll note, they're offset. Actually, no, they're not offset 90 degrees. Interesting. They're offset like 110 degrees. But you need two in order. So what happens is hydraulic flow comes through here, does the magic in here, makes this twist, this turns around, that chopper shaft actuates these proximity switches and sends out a pulse to the computer counts up whatever. That way you can calculate how much flow is going through here very accurately. The reason they have two and they're offset is because depending on which one fires first, you can determine the direction of rotation. That means these are not unidirectional flow meters. It'll flow in and flow out. That's very important for a robot because we don't just care about it lifting up, we also care about it lifting down. And here we have, it's sealed up. Now this is the non-pressure side. No, actually this would be pressure. Wow. So that's incredible because this is 250 bar. That's, well, what's that? Almost 5,000 PSI. Almost 5,000 pounds per square inch. You know, I respect you metric guys, but come on. A bar versus a pound per square inch. Pound per square inch. The nostalgia, I mean, that's a unit you can sink your teeth into. In any case, as I was saying, the O-ring here, if you look at this, you would think at first glance, at first blush, you would think that the O-ring groove would need to fill, the O-ring would need to fill that whole groove in order to seal. But actually, if you fill the whole O-ring groove, it doesn't seal at all. It extrudes, and you get a world of hurt. So what you need to do is, and there's specs for this, but you actually make the O-ring groove bigger than the O-ring so that it has room to crush. And it's all specified by the seal manufacturer, Parker or whoever. And yeah, you need very little crush on these O-rings in order to get them to seal to very, very high pressure. Of course, these O-rings are just Buna and jelly bean parts. You know, there's no need, if you buy one from Parker or you buy one from Guangzhou Charlie, they're essentially going to be the same, except they don't, you know, if you need to track them for something, obviously you're going to buy them from Parker. But anyway, Buna N, nitrile, rubber, and no, oil does not eat these. My God, if oil ate these, hydraulics wouldn't work. So you don't need any special silicone grease or anything like that. Just when you install them, a little oil or a little grease to keep them in there like glue, you're set. As I was saying, interesting, this is a pressure path, and we can see here, we just got some UHMW, ultra high molecular weight plastic. It looks like plastic. It might be Teflon. No, it's just UHMW in there. And that's where the proc switches goes. That's what seals it up. Incredible, eh? It's surprising that can withstand 5,000 PSI, but... Now this is a interesting design feature here. Why would you have these big long fittings? There's no reason to, really, because you could just mount a fitting right into this gland, and it must be something to do with ensuring that there's laminar flow. It's not a check valve because, as I said, it's got to go back and forth. Or does it? Ah, yeah, I'm mistaken. I'm mistaken. This is a check valve. So flow can only go in the direction that the arrow is pointing. Aha. So how do we get measurement in both directions? Well, this has to be installed in front of the DCV, the directional control valve. So flow goes into the directional control valve, and then it will decide whether it's going to the gland end or the rod end of the cylinder. So the computer would actually need to know, you know, whatever position you put that in, whether it's filling the cylinder or retracting the cylinder. But then there's a differential in volume there. There's a little bit more than meets the eye to this. It might not be as plug and play as I thought. But anyway, that's for future project videos. This is the Teardown. And yeah, sure enough, one-way check valve. So yeah, it's like a diode for hot oil. The mind boggles. So this is a little tough to get out. There's a retaining sleeve, a half retaining sleeve. Look at that. Wow. So because it can't be full because there's a bearing there, they turn that, look at the pattern, they turn that on the lathe and then they slice it lengthwise. That's an expensive part right there. And of course, it's not sprung at all. It's just the right size. Yeah. By sprung, I mean you don't have to compress it to fit it in that bore. And that's that abuts against this, keeps that secondary shaft in place. There we go. There's the money shot there. Whoa. And this looks for all the world like a screw compressor. Actually, you could make this a pumping element as well if you input mechanical power on this shaft instead of outputting mechanical power just to turn this chopper shaft. Now just imagine the cost of getting these toleranced so you only have friction or bypass losses of 0.1% at 5,000 psi. It's incredible. Incredible. Well, oil would have to come in the one side, the bottom side, and then it would have to be pressurized, or the flow would pressurize this in order to get this to turn. And that has to stay, instead of threading up, it has to stay in position. So both of these need to turn. So if you ever had one of these that was seized, you would know, like that wouldn't flow, you wouldn't get any flow through here because both of these need to turn. Now, knowing that this is unidirectional, why would you bother having two proc switches? I guess just for redundancy and higher resolution. I mean, this chopper shaft, 1, 2, 3, 4, 5, 6 signals per rotation. This way you get 12 instead. You want to talk about skookum. Look at the chunk of metal this is made from. Look at the depth of that bore. That all has to be match fit, honed. Incredible. Not so much on the engineering side, but on the manufacturing engineering side. The work that would go into getting this dialed in for a CNC process. I mean, hats off. And look at this, the touches are incredible, really beautiful. So on the one side, we have no dowel pins whatsoever, so you can't mix it up. And on the other side, we have two dowel pins to get this exactly in the right spot. Not that it's really needed because it seals on an O-ring. However, look at this. They've also made the dowel pins different lengths. So you couldn't put it together wrong if you wanted to. See, look at that. I cannibalized a proc switch from the other side. And I don't know if these are PNP or NPN. The difference being one, on the computer pin, it either connects to ground, so the computer sees a low voltage, counts as one, or it connects to high, so the computer sees voltage there and that counts as one. Well, I won't really get into it, but there's an advantage to both sides. But the main advantage is if you're using a syncing one, which is it connects it to low, then something fail safe. It escapes me, but somebody in the comments will tell me the difference between PNP and NPN. I can't give you everything, you gotta do some research on your own. The other thing that might be happening, the reason why we have two, is just for error checking. So if this is actually turning, the computer would be expecting this one to fire and then this one, or whatever. It would expect it would be expecting alternating firing positions here. It would look for this one and then this one, and if one fired twice in a row, the computer would trigger a fault because we'd know something's wrong. Either this is backflowing, or this guy's dead, or this guy's dead, or whatever. Oh man. Jesus, I think I was turning on that the wrong way. Surprised it didn't blow up in my face. Just showing you the way you would do this in the field, which is completely cobbled together and half-assed. Mainly because I'm too lazy to take the camera out of the vise. Well, not too, well, yeah, I guess that's the right word. Too lazy. Call a spade, yeah. There we go. Much more better. Now guys ask me all the time what tools they should have. And I gotta say, if you don't know what tool you need, you don't need it. You know, there's no point in having a 12-inch bearing splitter and a 4-pound slide hammer if you never use the fucking thing, right? I will say though, if you're starting out, nothing better than a skookum ventrise and a bench. Let's have a look at this here check-em-a valve. That is not a check valve. You see they broached that hole hexagonally, and it's threaded internally all the way. There's some funny shit going on in there. And take it apart. RTFM. Ain't nobody got time for that. Is this gonna blast me in the face like last Saturday night? No. What the fuck is this? This is so bizarre, man. There's a washer. Oh, wait. I have an idea. Pro tip. The vise on vices. Oh, it's some sort of diffuser. Filter. Keeps the ball bearings out. Wow. Those crazy Austrians. Who knew? It's friggin' serialized, man. Oh. A little bit of schmoo. Just ignore that. That's, yeah. On the outside of the thing, you know. I betcha $500 probably wouldn't buy that. This is interesting though. This is the retaining nut here with the internal hex, but obviously not a rotary broach because it gave way right there. And then they cadmium plated this. This is some sort of zinc cadmium 11 herbs and spices. I gotta say, man, this thing, zero fuckery. She is an official skookum choocher. And these, as you can imagine, no surprise, hard as frig. File just skates across there. Even the chop shaft. It's 2 parts here, but it's hardened as well. Interesting little feature. Hey, no spring washer. It's a socket head cap screw. Those are called Nord locks, and they're the only lock washers that actually fucking work. It should be legislated that they do not sell lock washers, spring washers anymore, because they don't work. They're a total waste of money. Yet there's a legacy involved that people still use them. You know, oh, gotta use a lock washer. No. These Nord locks, they're like ratcheted tooth. The only problem is they're very hard, which makes them brittle. So they do break. They wouldn't break in this application, but high vibration application, they do break, and then you need to take the whole fastener out to replace them. But these are the only lock washers that I've come across that actually work. Okay, I'll admit it. I was going to be that guy that tells you all about it and then not shows you. I got a little deal with my wife that she would make me scallop potatoes if I sliced up all the potatoes, and she's calling me, so I wanted to get this fucking done. But anyway, I'm not that guy. I'm going to show you here. Now watch this. I'm loosening it off, and it's going to... Oh, fuck. So it actually had to overcome that. Oh, you can see there. You can see. A picture is worth 1,000 words of video. Worth 1,000,000. Okay, focus, you fuck. Hey! Holy shit. $2,000. My God, it was worth it. Okay, so check it out. See, these little teeth engage on the head of the fastener and the fastenee, and then in betwixt the two is a more toothy, less toothy. What would you call that? Ruggeder. Anyway, you can see there. So when you tighten it up, they slip on each other. They ratchet on each other. Tick, tick, tick. And then to loosen them off, they do not want to loosen off. So you have to overcome them and go, pluck. Nord locks. Only lock washer that actually works. Unless we're talking electronics and small fasteners. Totally different kettle of fish. I'm not going to take that off because it's been Loctited. Yoo-hoo. There we go. Hey, we're 2 for 2. It's been Loctited on there. And as I said, these are big ticket items, man. I wouldn't want to have to buy this again. Put it that way. And these are all FAG bearings. FAG. So Skookum, made in Germany. Fabriekwerks, Antwerp, Guten Tag. So that is another piece of the puzzle saying that we can only, well, it is unidirectional because this is set up. Yeah, you know what? I don't know about that whole one-way thing. We'll have to do some more digging. So, as it turns out, because these are not check valves, they're actually little ball bearing catchers. This is bidirectional. So I thought I was wrong. Turns out I was mistaken. That, my friends, is where the rubber meets the road insofar as super expensive, high-end hydraulic automation equipment. You'll be seeing more of these two babies in the coming decades as I build up the hydraulic bartending robot. I try and buy parts on the cheap. I haven't been able to find a proportional valve. Guys are keeping their ears to the ground, but they just don't show up that often, and they are super expensive. So at this point, it's my time and some of the components that are the hang-up. But yeah, I think you'll be... I do have some more rotary joints. Those are hard to come by too because they use them in man lifts. Son of a diddly, who knew? But thank you, gentlemen. A tip of the hat. You know who you are. Thanks a lot for watching. Keep your stick on the ice.